All right, let's dive in. We're going to peek inside what can feel like a total magic black box, the large language model. You've definitely used them, you've probably been wowed by them, but how do they actually work? Let's pull back the curtain. I mean, just look at this haiku. It's got a vibe, right? It's funny, it tells a little story, and a machine wrote it, a computer. When you see something like that, it's really, really easy to just throw your hands up and say, yep, it's magic. But here's the thing, it's not magic. So that gets us to the big question, the one we're here to answer. How on earth can a machine, a thing of pure logic and code, write a poem about a hungry cat? Well, what we're talking about is a large language model, or an LLM. And the key here is in the name. It's a model that's just so massive, trained on, a huge chunk of the internet, that it gets this incredible ability to understand and generate language that feels human. Think of it less like a thinking brain and more like an insanely sophisticated assembly line for words. And just like any assembly line, it follows a pretty clear process. First, it chops up our language into little bits. Then its context engine figures out how all those bits relate to each other. After that, it makes a highly educated guess about what bit should come next. And finally, it delivers the answer. So, you ready? Let's walk through it step by step. First stop, the language chop shop. This is a process called tokenization. See, before a computer can read anything we write, it has to break our language down into pieces that it can actually work with. Okay, so let's feed a simple phrase into our assembly line. We type in, monarch butterflies lay eggs on 2. To you and me, that's just a string of words. But to the machine, it's just a bunch of pixels it doesn't understand. At least, not yet. And boom, this is tokenization in action. The machine takes our words and turns them into a sequence of numbers, or tokens. Monarch becomes 7088. Even a word like butterflies might get chopped up into smaller pieces. This is the language the machine actually speaks. It doesn't speak English, it speaks math. So now we've got a string of numbers. What's next? Well, the model has to figure out how they all relate to each other. This is where the real power comes in, thanks to something called a transformer architecture. This is how it builds context. The model doesn't just look at one number at a time. No way. It has something called a context window, and it uses that to pay attention to the entire sequence as it's being built. It's learning the relationships. It knows monarch butterflies are the subject here, and that they're doing something with eggs, and that's happening on the leaves of something. And this ability to look back at the whole history of the conversation, that's the secret sauce. That's what makes these new LLMs so incredibly coherent. It holds the entire sentence, or, our entire chat history, in its working memory so it can see the full picture. This is what keeps it from just spitting out totally random words. Okay, so with all that context understood, what does the model actually do? And this is the most important part to get. It doesn't know the answer like you or I do. It makes a prediction, an incredibly sophisticated, data-driven guess. So based on the trillions of sentences it's read during its training, the model creates a huge list of every possible word or token that could come next, and then it assigns a probability score to each one. So after monarch butterflies lay eggs on, the token for milk might have, say, a 7% chance of being next. Plant has a 2% chance. And some nonsense token like Zucks, that gets a 0% chance. And this chart really lets you see it clearly. This isn't just a random choice. Based on all that context we talked about, the model calculates that milk is the most likely next piece of the puzzle. So it picks that token, adds it to the sentence, and then it does the entire process all over again for the very next token. And that, right there, is the heart of it all. At their core, these massive, complex LLMs are just incredibly powerful next token predictors. That whole cat poem from the beginning, it was built one single predicted token at a time. It's a chain of probabilities, not a chain of thought. So now that we've seen the whole assembly line in action, from our words to numbers to probabilities and back to words, we can finally understand both the amazing strengths and, the really surprising weaknesses of this technology. And what's wild is that the LLM's biggest strength, its creativity, is also its biggest weakness. Because it's just a pattern-matching machine, a predictor. It's not a fact-checker. So it can unknowingly make stuff up. We call that a hallucination. It's absolutely brilliant with grammar and patterns, but it has zero concept of truth. All it knows is what is most likely to come next. Which, of course, brings us to the final, really big question. If this unbelievably complex system is just predicting the most probable next token in a sequence, all based on math and patterns, is it truly understanding language? Or is it just the most astonishing mimic we've ever created? Something to think about.